Hi guys, my name is Peter C. Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's lecture, I will be discussing finding derivatives of functions by means of the methods of differentiation. And like we derive the different methods of differentiation, so we want to apply them. So in the previous video, we did some examples involving finding the derivative of the power rule, or let's say derivative of functions using the power rule. And this is the power rule. This is the constant rule. This is the constant multiplier rule or the scalar rule. So we want to apply particularly the power rule, and if possible, the constant multiplier rule or the constant rule in either of these two problems. So the first problem says that we must find the derivative of y equals to 3 divided by x to the fourth power minus 2 divide x squared plus 3x. And the next problem says 3 over 2 x to the fifth power minus x to the minus 5 minus 3 over x squared. So what we need to take note of is that we said the power rule is if you have a function raised to n, it means its derivative y prime is equals to n x raised to the power n minus 1. So this problem, this is not in the form of a fraction. So our first and foremost concern is to rewrite this problem into a form that we will have of this form, x to some n. Because x is within the numerator, so we must make each of these denominators, these variables in the denominators to be in the numerators. So we have the first one. We send this x to the fourth power within the numerator. And when a variable or a term or an expression is leaving the denominator and going to the numerator, the sign of that expression changes. If, for example, you have x squared down here, and you want to send this x squared on top, this will be equal to x raised to the power minus 2. If this was x squared over 2, and you want to send this x squared in the denominator, this will be 1 all over 2x raised to the power minus 2. If in the denominator it was x to the power minus 2, and you want to send it in the numerator, the power will change to x raised to the power positive 2. So if it was negative, it will change to positive, and if it was negative, if it was positive, it's going to change to negative. So in this case, these are all positive, so they must be converted to negative. So we have 3x raised to the power minus 4, and this one you have minus 2x raised to the power minus 2 plus 3 times x. Now, because each term is in this form, we can now apply the power rule. So we say y prime. Now note that we did not put prime here because we were not differentiating. Y prime is equal to, now some books or some students or some teacher will want you to use the notation, the derivative notation, that is the dy by dx. The dy by dx. So you can rewrite this thing as dy by dx equals. Now some other instructors will want you to follow step by step. That is, they want you to show them how are you differentiating. So we can say we read it 3 and we want to differentiate this x raised to the power minus 4. So we read a derivative notation d by dx. Now the reason why I'm using the x here is because the variable is x. If this was t, I would have used t. If it was arrow, I would have used arrow. So this d divided by dx, it is a derivative notation. It indicates that you are about to differentiate this expression. So we have minus 2 times d by dx of x raised to the power minus 2. Then we have plus 3 times d by dx of x. So some teachers want you to, follow the steps, and so you can just use this method. So we got d by dx is equal 3. Now we differentiate this one. So we bring this power down, minus 4. We rewrite this expression x and raise it to the power minus 4. Then we subtract 1 from the power. Remember, n minus 1. So this n is minus 4, so you subtract 1 from it. Minus 2, we bring this 2 down, times minus 2. Then we rewrite x. So if you are differentiating now, you no longer include this notation. So we have minus 2 now, minus 1, because the rule says we must subtract 1 from the power. Plus 3. Now again, this is just x. So x to the first power will bring 1 down, and we subtract 1 from x to the first power. We just left with 0. We just left with 0. So dy by dx is equal 3 times 4 is 12. So it's minus 12 now. X raised to the power minus 4 and minus 1. The signs are the same. We add minus 5. Minus times minus is positive. The signs again are the same. We add minus 3 plus 3. X raised to the power 0 is just 1. So normally when your final answer, when you have negative in the power of the variables, you rewrite them. That is, when the power is negative, it is in the numerator, you send it to the denominator. When it is in the denominator, you send it to the numerator. So we bring this expression down. So 12 is on top. We don't carry 12 down. On at x. So it's x raised to the power positive 5 plus, this second one now is okay, so the second term here we have 2 times 2 is 4, right? So it's 4 divided by x raised to the power positive 3 plus 3. So this is now our derivative. So let's do the next one. So again, the first thing you need to do is to ensure that all of the terms are within, the variables of all of the terms are within the numerator. The variable, your concentration is a variable. So this one, we have to rewrite it. So it is not the number that, this is just a coefficient. So you are not bothered by this. So you rewrite this 3 over 2x to the 5th power minus x to the minus 5 minus 3. Now we send this x to the positive 2 on top. It will be minus 2. So we differentiate now. F prime of x equals. So we just multiply this 5. So it's 3 over 2 times 5. So it's x. So we subtract 1 from this 5 now. 5 minus 1. Minus. We bring this minus 5 down. Minus 5. We rewrite x and subtract 1 from minus 5. So 3. We bring that minus 2 down. Rewrite x and subtract 1 from minus 2. So now we have f prime of x now to be 5 times 3 is 15 over 2. X raised to the power 5 minus 1 is 4. Negative times negative is positive 5. So you have x raised to the power minus 1, minus 5 and minus 1 is minus 6. Negative times negative is also positive. 3 times 2 is 6. X raised to the power minus 3. The signs are the same. So again, when your final answer, you have negatives within the powers of the variables, you can reciprocate. So in the first case, we have 15 over 2, x raised to the power 4 plus 5 all over x to the power. Now it goes down as positive 6 plus 6, it goes down as positive 3, x to the power positive 3. So this is the derivative of the function in question 4b. So thanks also much for watching. See you in our next video.